So this is a quick video about concepts of projectile motion, just so that you can understand what factors influence horizontal displacement and how. So we know that a projectile is something that is shot into air and it follows a parabolic path to the ground. The only force that influences the projectile is the force of gravity. So that means the easiest way to understand projectile motion is to think of it as two motions made up together. One is horizontal and the vertical. The horizontal motion is not influenced by any acceleration, so therefore the velocity horizontally stays constant. But the vertical motion is influenced by gravity. So that means while it is going up, it is going against gravity, so its vertical velocity will decrease, becomes 0 at the top, and then while falling down, it's falling in the direction of acceleration to gravity, so its velocity will increase all the way down. So vertical velocity is influenced by gravity. So there are three things that decide the trajectory of the projectile. One is what is the speed with which you're throwing, what angle at which you're throwing, and what height from which you're throwing. So you can write, this is the horizontal displacement that it undergoes, and this horizontal displacement, because you know horizontal velocity is constant, so you can just write horizontal displacement as simply displacement is velocity times time. Distance is speed times time, right? So therefore there's no change in the velocity, it stays the same. So this is your equation that influences the horizontal displacement. So if you think of each variable, velocity, angle, and height, and how this influences this equation, we can understand how these change or affect the horizontal displacement. For example, if you take speed, if you change the speed, so remember we have to divide speed into two components or velocity into two components in order to understand how the projectile motion works. So you can divide this into two components, Vx and Vy. So if you increase the velocity, Vx will go up, but so will Vy. And remember, the vertical component is what decides the time, because if you give it a high vertical velocity, it's going to take longer to go up until the speed becomes 0. So it's going to stay for a longer time in air. So increasing the velocity increases horizontal component as well as the vertical component, which in turn decides the time. So that is how it is going to affect the horizontal displacement. Now let's talk about increase in angle. So if you increase the angle, then this will go up. The vertical component will go up, because you see, if you have the same velocity at a bigger angle, this will increase. But you know that if Vy increases, Vx has to decrease. So then increasing the angle will increase the time, but then it will make this shorter. Decreasing the angle will make this larger, the horizontal component larger, but it will make the vertical component shorter. That is why you see, when you change the angle, one of the products, Vx and delta time, one of them increases, the other one decreases. That is why there is a magical value at which the displacement becomes maximum. There is one angle at which the displacement is maximum. After that, again, it starts to decrease. Okay. Then let's talk about how height influences this. So you can clearly see, if it's projected from a higher level, it's going to take longer to fall to the ground. But height is not going to do anything to Vx. Vx is unaffected by height. So height will only influence the time. So longer height means longer time. And this does not change at all. And so now you can see how this affects delta x. So I have given you some hints on how to develop the reasoning here. So feel free to use it in your concept.